Okay, it's a few minutes after the top of the hour, and I'd like to formally welcome everybody to the session entitled Building Multi-Line of Business Shared Clouds, all about how we have worked with a leading company to build an enterprise cloud that has all the advantages of consolidation without forcing the line of businesses to lose control. So this will be a real-world customer example. I want to take a moment and introduce the two people that will be speaking today. There's myself, Jay Muehlhofer. I am the VP of Marketing at Platform Computing. You can see my contact information there, as well as James Pang, who will be doing the bulk of today's session, talking about the specifics of the customer and their implementation. For those of you who may not be aware of who Platform Computing is, we're actually a 19-year-old company that has been a leader in managing large-scale shared environments. And by large-scale shared environments, we mean anything from clusters, grids, to now clouds as people have evolved their computing environments. We have over 2,000 customers across the globe, as well as 9 of the 10 largest companies and 23 of the top 30 companies in the world using our solutions to help them better scale their environments. You can see the CPU number there, which is pretty impressive, and we are headquartered out of Toronto, Canada, and have relationships with most of the other major technology vendors. Today, we're talking about cloud, and cloud is a very exciting thing, but one of the things that I wanted to bring out at the beginning of this session is that we actually think about cloud in two different spaces. So Platform Computing has a long heritage in the high-performance computing space, as well as all the work that we're now doing in the enterprise space around clouds and MapReduce. But when we're going to be talking today, it's going to be very focused on the enterprise side, but I did want to take a moment and just make everyone aware that we're doing a lot on the HPC side, where we're taking those environments and actually bringing them out into the cloud in a couple different ways, either by morphing or harvesting existing infrastructure, but we're also doing a lot of stuff about cloud bursting, connecting people out to Amazon for dynamic workloads, as well as running our HPC solutions 100% in the cloud. So you can actually go to Amazon Marketplace and get that solution there. But today we're going to be focusing more on the enterprise space around the infrastructure as a service, and you can see the details there, but I just wanted to make everyone aware of that. So when we're talking about cloud and how we think about it and our customers ask us about it, in the enterprise space, it's very interesting. There's always this tension between the business units and what they're wanting and IT. And I think this has really been predicated by the emergence of Google and Amazon. But all the business units today, they want the faster delivery, they want the self-service they can see out of Amazon, and they really do want to lower costs. So I know everyone talks about the whole agility question around cloud, but still I just want to remind people it's all about cost at the end of the day. But they're not willing to sacrifice SLAs. The tension here is that IT, while they're being asked to enable self-service, they still have to manage the everyday business. They're trying to push on virtualization and really take that utilization from the 10% level up to multiples of that. So how do they do that, and how do they really get those operational efficiencies that really increase the number of servers that are administered by users and still get additional server consolidation? And that really is what we're going to be talking about today, because for the IT organization, there is this tension between line of business's desire to own and operate their own environment. Here in the graph, you can see each one of those is represented as silos. And the challenge is they're investing in it at low utilization because there's not sharing across business units or even within sub-departments within businesses. And in each of these environments, people do have different technology platforms that they're pushing. So in the F1000 space, VMware is pretty much a standard in terms of a lot of what they're doing, but people do want to leverage KVM. They do want to look at other different hypervisors and how they can expand that footprint and maybe have flexibility because you don't know what's coming down the road 5 years from now. Not everything is virtualized. There's still people who are doing the bare metal. And it's really the administration complexity of managing all this really is kind of the antithesis of what cloud is all about. So that's really what we're going to be talking about today for this company and how they addressed each of these challenges. And finally, at the end of the day, people don't want to be locked in. They do want to be able to have that choice. So I'm now going to hand it over to James, who is going to be talking about a specific customer case study and how they approach this concept of a shared private cloud infrastructure.
Okay, thank you, Jay. So So first, I also want to welcome everybody on the call. So as we going to give an overview of this particular customer case, we'll first describe what their organization looked like. We're going to first describe what were their the pains and the drivers that led them to move towards this cloud project, and then we'll give more flavors on the actual technology, the implementation around the Platform ISF product, which is the basis for their cloud implementation. So first, let me describe a little bit about this customer. And again, this is really an example customer. We have seen many other customers that have similar profiles in a similar use case. So with respect to this particular customer example, it is a very large engineering conglomerate, multi-geography, organized in typically a very large organizations along many lines of businesses. And with lines of business, some may be focused on research, some may be focused more on service delivery to their end user customer, et cetera. So it's a very large, fairly complex, multi-layer company. And within each lines of business, typically you see multiple departments with the different focuses, and departments underneath might have different projects. So with respect to this organization, there are diverse areas of focus, multiple centers of expertise, and with respect to the requirements on IT, it is obviously quite a headache. The requirements change. There are different deadlines, different types of needs based on the most critical priorities. So it's quite a challenge with respect to how IT is run and organized to support this very large organization. So to give you a sense of the previous current state of the customer environment, because they were organized along lines of businesses, IT itself was broken up between a shared corporate IT services, such as email, such as user security, et cetera. But the bulk of the work that is tied to the business units is actually in what is called the line of business IT. And so it's the actual lines of business IT that, being closer to the businesses, to the projects, are the ones who are managing the local infrastructure so that they can more effectively deliver and meet the requirements of the projects and particular businesses. So what you see basically is that you have silos across the different lines of business, and even within the lines of business, typically you might also have silos within departments with respect to the various infrastructure. So with respect to this type of organization and the pains that they've gone through, they identify a number of key drivers that led them to this journey of thinking, is there a better way to do this? Instead of having all these different silos, instead of having all these duplication, is there a more effective way to deliver shared services to the organization? So some of the specific points that led them on this journey to move forward with the cloud project include that a lot of these lines of businesses and a lot of these departments have very old hardware. They still depend on them. And one of the reasons why is because they have very tight budget. On the other hand, they know they have to change. So there is a need at each of the line of business, at each of the department, to make a transition. So this is one of the catalysts for them to think, since you have to make a change anyways, is there a better way to move forward? Okay. Another key driver is simply that they know there is lots and lots of duplication. There is a lot of reinventing the wheel. There is a lack of shared practices among the different lines of business. And one of the kind of examples say there's like 10 ways of doing the same thing with respect to how everything is organized. So the inability to share, reinventing the wheel, losing time are really key pains that they were going through. But at the same time, they felt they need that control to be close to the businesses, to be close to their customers, to be close to their engineers. So hence, that is where they're having quite a dilemma. How do you enable more sharing, but at the same time maintain that ownership, that control, and that tie-in back to the the businesses and the projects. Okay. So some of the other things that were also key drivers for them to move towards this cloud project include this idea of visibility, management of application license. They're just all over the place. So while infrastructure itself is expensive, application licenses are even more expensive. So they're thinking there must be a better way to share these licenses. There must be a better way to ensure that they get the most out of these very, very heavy investment of their application licenses. And finally, with this very distributed IT organization, the local admins are very, very tied up, right? Their workload is very high, and it's just bursting at their seams in terms of how they need to service the various lines of businesses. So these drivers lead to then the identified project goals. So as you can tell from an example, from this particular customer example, they were actually very organized right from the beginning in terms of clearly defining why they're doing the project and how we're going to measure if the project is going to be successful or not. So they identified clearly 6 key items on after they achieve the goals of the project, what would they be? So that includes going back to the fundamental pain points that they want to have this idea of shared infrastructure service. Okay, but at the same time, they want to be able to leverage a lot of their existing investment they have done already in virtualization in their applications. For example, in one of the key items that they must leverage is VMware, the vSphere investments that each of the different lines of business projects have been making over the last 10 years. They're a heavy VMware shop, and they want to re-leverage that investment. Other things with respect to project obviously is really tying into the vision of cloud. This idea of self-service, this idea that you don't need the administrators to be involved with everything. This idea of directly empowering the end user developers, the end user engineers, the end user customers, and then be able to monitor and charge back on a pay-per-use basis. That is really what they tie to in terms of the vision and the ultimate goal. Everything is self-serviceable. Okay? And all these things sounds great, right? Being able to share, at the same time leverage what they have. But again, the flip side is they still need to maintain security. They still need to maintain the protection of IP. So how can they do that? Okay, so there's that two complementary and in many cases conflicting goals to get drivers towards the goal. And finally, at the end of the day, as Jay mentioned earlier, it is about cost, right? And cost in the sense of capital cost and also cost in the sense of operational. Right? At the end of the day, this whole infrastructure, if they monetize it, has to be significantly cheaper than if everybody went off to the external cloud. It has to be significantly cheaper than the way they were doing things. Otherwise, there's no point in making this change. And the last point is actually a very, very important point, as they realize very early on, as they embrace this idea of cloud, that cloud computing is not just about technology. That cloud is about customer service, and part of that customer service is to ensure that the various lines of business, the stakeholders, have a sense of empowerment, that they are part of the cloud project. They are part of this solution. So in that sense, that was actually one of the key lessons that they learned, and one of the guiding principle as they embark on this cloud journey. One, and that point mainly is that it is not just about technology, and it is not just build it and people will come. It is about embracing your customers. It is about having your customers and the lines of business folks and all the stakeholders feel they are part of this move towards a cloud infrastructure. So with that guidance, a lot of effort was made prior to even talking technology to listen to the lines of business, to listen to the various project managers, to listen to the various departmental heads. And this was a key attribute of this overall journey, this overall project, that enable them to then get to a solid technology foundation and ultimately delivering to a very successful first milestone. So some of the things they heard from the lines of business include, from their own words about concern about lock-in. What if things change in the future? What if there's a better system out there? How can you ensure that there is flexibility, there is option moving forward? How can they ensure that there is fast turnaround time if you move to a shared infrastructure? How can you ensure that they get the same level of control as what they had before? Because at the end of the day, the end users, the scientists, the researchers, they care about their own productivity. That's the most important thing to the organization, the productivity of the engineers, the scientists, and with respect to providing service for folks outside of the organization, it is the SLAs that are guaranteed, that are promised to deliver to their external customers. And then finally, as we mentioned earlier, this idea that, yes, cloud computing is a paradigm shift in how you want to deliver IT, but at the same time, there are a lot of complementary processes and tools that need to be integrated and leveraged with respect to the new way of doing shared infrastructure, of delivering the IT services. So these include things like being able to tie into their existing trouble ticketing system, being able to tie into their entitlement system. Those are all complementary things that this cloud infrastructure has to be able to tie into. Okay. And then finally, as we mentioned earlier, the big concern about, is this all going to cost less? So with that, if you break down the process they went through, it was a very deliberate, consultative, and very comprehensive process. And these are some of the major milestones that they had undertaken. So they include requirement definition, vendor discovery, and that's how platform was part of the journey. Definition of services, that was a key line item, to be able to go and define a set of standard services instead of having 10,000 different templates as an example. But how can you break that down to, synthesize that down to a few? Standardization. How can you get to a standard set of application stacks, as an example, instead of 10,000 different ways of doing the same thing? How can you standardize on that? So a lot of effort was placed on that. And then from there, as we mentioned earlier, customer engagement, and in respect to customer, it means the lines of business, the departmental. And that's also part of that process, is how they get secure funding to build a business case, get buy-in, and able to build the funding model for this project. So after that, with respect to the technology itself, vendor selection, it's actually it's actually much easier once you can get to the technology stage of the project, of vendor selection, workflow design, alpha beta implementation, and finally at the end, the issues of bringing in training and having people being aware of a different way, but hopefully a better way of accessing IT services. And the last item is probably the most important. For a lot of these cloud projects to be successful, it needs to be iterative. So initial feedback, have a first release, and then iterate again on a second phase. This iterative approach has been found to be much more effective than a traditional kind of a waterfall, one big bang approach to implementing cloud projects. So as we said earlier with respect to the topic of this session, it is a very pragmatic and very iterative approach to getting to cloud projects. So with respect to that, the technology that was chosen to be the infrastructure service management is called Platform ISF. So at this point, I'll give you some sense of moving into the ISF overview and how it is play into this overall cloud project. So after the initial major milestones, a shared service was provided from an infrastructure service perspective. Lines of business now able to go to the central IT service and have the self-service pole, essentially being able to self-service and get their own private VMware environments. So a lot of the initial goals we discussed in terms of the benefits were achieved as a first-level milestone. So this includes having reduction in administrators, reduction in cycle time, having the chargeback and accounting to support the pay-per-use model, and overall just getting the initial benefits of getting into the cloud investment. And as we mentioned earlier, the flexibility moving forward is very, very important. And so the whole framework allows them to consider any changes in the future. Okay, so at this point, I will dig into the next level of detail on one of the key items of the infrastructure management software called Platform ISF, and how it helped this organization to deliver the infrastructure service and deliver the benefits that we had just described. So right off the bat, as we had started this session, we talk about the organization. So one of the key requirements that they were looking for in terms of a cloud management software is a management software that has out-of-the-box built-in paradigms that represent and reflect their organization. As we saw earlier, the organization is multi-tier, it's multi-level, and ISF does provide this paradigm right out of the box. As you can see here with the various screenshots, you can see the various departments, the lines of business, and under the departments, you have specific projects. And for each one of these areas, you can specify, as seen on the left-hand side here in the screen, the amount of resource allocation that could be allocated and assigned to each of the groups. And depending on the day of the week, depending on the time of the day, some groups should and we may require higher priority than others. And that's where, from the top level administrator point of view, they can set the relative allocation of the resources. So immediately this allows them to ensure that the resources are allocated and aligned with the business priorities of the various projects. At the same time, if you look at what is behind this, this does enable them to, on a line of business perspective, to basically create their own resource pools. And behind the scenes here, they're actually doing self-service creation of VMware resource pools and DRS entities. So this was a huge and important characteristic requirement that they needed, which is that they needed to have that control as they were having before when everything was running in the silo. But of course, right now, they get the benefit that this is now a part of a shared infrastructure and that they can grow and shrink the relative amount of resources as needed. Okay. Then the next item that was very important was going back to the issue of leveraging their existing investment, right? Especially with respect to virtualization, which they have been on the journey in the last 6 to 8 years. They're heavily virtualized from a sense that they've got their up to 60, 70% virtualization. Of course, all these virtualization are done in a silo manner within the line of business, within departments. And now we're bringing it up so that it is a shared virtualization environment. So one of the key drivers they were looking for is a deep integration with their initial hypervisor, obviously, which is VMware vSphere. And Platform ISF offers that quite tight integration with a lot of the VMware vSphere functionalities. In fact, fundamentally, they didn't have to remove or lose any VMware vSphere features when they went into this shared service mode. So for example, as I mentioned earlier, the vSphere, the DRS functionality is fully supported. All the migration capabilities in vSphere is fully supported. HA is supported. Things like snapshot is supported. Things like link clones are supported. Concept of virtual data center within vSphere are also supported. And at the same time, obviously, Platform ISF enables them to also have multiple virtual centers to be able to support multiple data centers across to support different departments and different lines of businesses. So that was a really key driver on making sure that the requirement that whatever management software they chose has very deep integration with the VMware vSphere. at the same time, many of the departmental businesses have been looking at alternatives for tier 2 types of applications. So that includes alternative hypervisors. That includes things like KVM, Citrix and servers. So they needed to ensure that as they move forward in time, that in the future, that they do have the option of tying in things like KVM and things like Citrix and server, and perhaps even like and Hyper-V as part of the shared services pool. So that was a key requirement, and that's what you can see here on the left-hand side: the Citrix and server support, Xen KVM support, Hyper-V, etc. And the other aspect, again, this idea of openness, that you don't want to be locked down, which was one of the concerns from the business units, is that if they needed to go outside of the firewall for certain applications and under certain bursty situations, that they have that option, and that when they go outside the firewall, it can be Amazon sometimes, or it can be Rackspace, or it can be one of the many VMware certified service providers that are out there. So they needed to have that option. So as you can tell here from here, just an example, EC2 was part of the selection criteria when they were going through this journey. Okay, so moving forward from here, let's talk about another very critical requirement as they were doing the evaluation of the selection of the cloud management layer. Okay. We talk a lot about infrastructure service. Obviously, that is one of the key use cases, a basic use case. But at the same time, at the end of the day, these VMs, this infrastructure is going to be used to run applications. So one of the key differentiator that they saw from Platform ISF is the much more convenient and much more user friendliness in supporting applications in the cloud, in this internal cloud. Okay, so this actually allows some of the lines of business, some of the departments themselves, actually from their perspective, after they added the application stack into ISF, that they're actually delivering PaaS, Platform as a Service. In some cases, after that, then when they're actually running in production, they're actually delivering software as a service for some of their sub-projects and some of the lines of business and departments. So as an example of the application support in Platform ISF, what you're seeing here is an example of a 3-tier application using based on WebSphere, with the front tier being a load balancer, the middle tier being the app servers, and then a backend tier being the Oracle server. So these concepts of application definitions in Platform ISF enables them to go beyond just delivering VMs, but also be able to deliver whole application stack. So after delivering the whole application stack in the runtime environment, they need the ability to be able to dynamically flex up and flex down. So some of the conditions for flexing or flex out includes looking at CPU utilization, as you can see in this example, which says if the utilization is more than 95%, go automatically flex up another WebSphere instance. And in some cases, even more importantly, is the idea of reclaim, which did not exist in their prior state of the silo infrastructures. So the idea we claim here in this example here is that if the utilization is less than 5%, go remove one of the WebSphere instances. Okay, and this is by having automatic flex up, automatic flex down. It goes a long way in helping them increase the overall utilization in meeting fluctuating SLA demands. And with respect to this organization, they were doing a lot of homegrown development. So what that means is that they were able to get some very application-specific metrics to drive the flexing up, flexing down. So in that context, what they were looking for in a cloud management solution would be a solution that's quite open, that allows any type of attributes and metrics, especially application-specific metrics, to be able to be inputted into ISF and use that as a condition to flex up or flex down. In other words, to represent what is really busy and what is not so busy. So very, very tightly tied to the particular SLA of the application. So the web server is one example. Other things, other types of applications that were very important to this particular organization include things like Hadoop, be able to deliver a full Hadoop stack, LAMP stack to do a lot of the web stuff, and finally be able to also have predefined images as necessary to go and jump over to Amazon. So that's what you're seeing here as some of the example screenshots for that were very key. That were key drivers of the cloud implementation at this particular organization. Now, from an end user perspective, and as an end user, those are guys you really need to keep them happy. And so these are the developers, these are the engineers, these are the guys, these are the IP of the company, right? The people who are contributing to the core business of the company. So these guys don't care about infrastructure, obviously. They want to be able to get what they need now and be able to do the work and support the businesses and be aligned with the different priorities. So they need very simple interface, and they don't mind looking at this cloud infrastructure as if it was really an infinite resource pool. Okay. So from an end user perspective, it's a very simple dashboard was a paradigm that was used. Icon-like displays. One of the feedback was that it should look like iTunes. Right? I should be able to just click and boom, I get my LAMP stack. Boom, I click, boom, I get my Cloudera stack. And then based on that, with the self-service capability, I should be able to do things like starting up, suspending, remote consoling in, even things like checkpointing, snapshotting, all without having to talk to the central IT guy. This is empowerment. This goes back to the earlier drivers and the earlier attributes that they were looking for as they were going through this cloud journey, empowering the end user, increasing their productivity, and ultimately also reducing in the back end the excess load of the various system ins. So this type of interface, user-friendly, tailorable to their particular need, were key things they needed to deliver in order to, again, to embrace and get the stakeholders on board to leverage this shared infrastructure. Okay. The other items of the self-service end user self-service capabilities include things like being able to support applications, as we described earlier, and one of the key attributes of when you want to run your application is calendar based, right? So it's a very simple concept, but in real life, it's a very common concept to be able to say when I want to run my application and when I don't need to, and to be able to do it in an automated fashion. So Platform ISF provides a full reservation system in the back end. And this helps both the end users to have a sense of guarantee of the resource that will be needed to support their application. At the same time, it also helps the IT staff, the cloud IT admins, in doing capacity management, be able to predict when they might be running out of capacity, and be able to start planning on when would they need to add additional servers and storage in order to meet the growing demand. So this really, this whole idea of reservation system built into ISF was a key component that helped both the end users as well as the IT staff to have better sense of what they have been using and what they need proactively in the future, and to be able to plan ahead in a much more proactive fashion instead of running around firefighting. Okay, so built into the ISF solutions includes the full capacity management, and it can apply to both physical, virtual, as well as being able to identify when resources will be needed outside of the internal cloud out to a public cloud. And more importantly, all of this data that runs through ISF are presented obviously in our out-of-box capacity management reports, but also all the data are available in an open database, published schema. And again, this is one of those line items that at the end of the day, they need access to the data. They need to be able to do some site-specific analysis of their workload and to make the planning for the future on when they do need to have more machines, or in some cases, less machines. So now I'll kind of go back to another role that is very important to the cloud infrastructure, which is the folks who are running the cloud, the administrators, right? And through this effort of consolidating these silos into one centralized infrastructure delivery foundation, a lot of the lines of business admins could focus on higher level, higher value services to support their lines of business and the business people there. For example, be able to help them deliver better applications. So that achieve one of the objectives of the project, which is to reduce the load of the local admins, allow them to focus on higher value things to the business. And for the cloud admins, which is the central team that is managing this shared infrastructure, they're able to manage it with in a much higher server to admin ratio than what was traditionally happening when they were in a more silo approach. Okay, so what are some of the key things that allow them to have a higher server to admin ratio? And the key component from Platform ISF is the operational monitoring, alerts, and event functionality built into ISF. And this is one of the unique multi-panel displays that enables the cloud admin to easily at any one time identify potential problems between going from applications to physical servers to VMs at a click, and be able to monitor what's happening in real time and be able to asynchronously get events and alerts on conditions to look at to raise alarms for situations that might be happening asynchronously. So this whole built-in operational monitoring alarm system is part of the ISF product. And as this cloud infrastructure project was going through, one of their concern was it has to be a lower cost. Right? I should not have to buy 10 different products in order to deliver the cloud infrastructure. That would defeat the original objective of going along this cloud journey. So with ISF, the guiding principle is always to be simple and to be integrated and to have all the necessary pieces you would need to manage the infrastructure, and not having the customer have to buy multiple products and try to glue them all together. Okay. So finally, we talked about the self-service. We talk about the infrastructure. We talk about the administration, how it how the ISF and the whole shared infrastructure allow to reduce administration costs. The final line item is to run this as if it was a service, as if it was a business, and that is ultimately tied back to the billing and the chargeback. Okay. As I mentioned earlier, everything that runs through the system, every self-service request, every resource is logged and into a public database, and all that data can be used to support billing, chargeback, capacity, in addition to capacity and allocation management. So the billing and chargeback is also built into the ISF product. Initially, the billing and the chargeback model were fairly simple. which is good. And ISF provides the flexibility where you can change some of the formulas. And moving forward, as the environment scales out, as they get more and more customers using it, the next logical step is to be tied into their own accounting and chargeback system. So that openness, right, is a key attribute that will be needed, and goes back to having that need to leverage a lot of the existing processes and a lot of the existing systems in the organization, and not just rip and replace everything. So this is an example of being able to leverage their existing accounting and chargeback system by virtue of having an open database for the customers to get at the data. Okay, so those are some examples from a technical implementation perspective of some of the key attributes that we're looking for at the technology level, and how Platform ISF as the IaaS management layer help to deliver to the and support their cloud project. And again, these are some of the examples, some of the highlights that circle back to the original objective of the project of sharing, but with control, right? And ultimately reducing costs from a people perspective, reducing costs from a capital perspective, and at the same time accelerating the productivity of the lines of business project teams, and increasing overall productivity of the local admins, so that they can focus on higher level services and higher value deliverables to the organization. So as a summary of some of the key concepts that match well into this particular customer case and this particular customer's requirements, include things like deep VMware integration. Okay, and that is really, in their initial step, being able to leverage the vSphere investment. And by deep VMware integration, it means they should not need to have to turn off any of the VMware vSphere features that they were happily using, even when they were in the silo days. So some of those capabilities, as mentioned earlier, include things like being able to leverage the DRS, and taking it one step further to be able to dynamically create, from a self-service perspective, these DRS resource pools at any level of the organization. So other examples of the VMware integration, to where we're talking about the snapshot support, link clones, leveraging the VMware's vDIS, the storage and the networking for supporting to meeting the data as well as the security requirements. Okay. A second item, again, in summary, as we saw right from the beginning, we show you a organizational chart of the company, and with respect to ISF, that comes right out of the box. It just maps very nicely to the multi-layer, and in real life, real organization, it is multi-layer. Just having one layer is just not good enough to be able to support a truly multi-lines of business, multi-project, multi-departmental consolidation, and deliver that as a shared service. And one of the uniqueness of ISF, one of the focus of ISF, is about applications. So yes, definitely ISF is a IaaS tool, and can easily support delivery of VMs and just operating system. But at the end of the day, you need to have the conveniences and abstractions, such as the application definitions in ISF, to ultimately support running of applications, to ultimately support if the customer needs to provide and extend that service to include platform as a service. Right? And so the app definition concept, being the application-centric focus of ISF, is a key thing as would be needed by any cloud projects. And then finally, just to wrap up on the recap some of the key concepts, the openness. So while we did talk a lot about VMware, but from a customer perspective, customer ROI perspective, and protection of the future, they need to have the option of including potentially other hypervisors, and that will help them drive costs down. And for a lot of tier 2 types of applications, other hypervisors are really, really effective. Okay? And as Jay mentioned earlier in the call about there are still physical systems, and for example, Oracle database servers is an example that need to run as on physical servers. The I/O performance in a lot of the hypervisors are not quite there yet for certain types of workloads. So you need to be able to include physical servers as part of this shared infrastructure. And obviously, the example we gave earlier where Oracle server being deployed as part of a 3-tier application makes a lot of sense, where the Oracle tier needs to be on physical, while the first 2 tiers, the load balancer and the app server running on VMs, is perfectly acceptable. Okay, so that's a very good example of a real-life 3-tier application of mixed VM and physical. Okay, and then finally, rapid provisioning of flexing up, flexing down, we claim. Right. Traditionally, again, this whole idea is easy to get more machines. In fact, virtualization, one of the lessons learned from the virtualization journeys is server VM sprawl. You got more servers than before, and because that did not address the issue of weak claim. Okay. Now with cloud, through the self-service, through the reservation systems, you are now capable of implementing a weak claim strategy so that you can reuse and ultimately save on servers, and actually ultimately also improving the productivity of the IT staff. Okay, which leads to the final concept about the cloud cockpit. At the end of the day, this whole thing, cloud, as mentioned earlier, cannot be more expensive than before, right? And it has to be competitive, cost-wise, business-wise, versus everything going outside the firewall. Okay, so we cover a lot of territory with respect to some of the examples, some of the screenshot of ISF, to kind of bring it up one more level as a summary of the different modules and capabilities of ISF that we have walked through, that include the resource integration, we saw the multi-hypervisor support, that include the allocation engine with respect to the policies to flex up, flex down. We talk about the self-service, we talk about the reporting, we talk about the application-centric support of ISF with respect to the app definition, and we rounded it out with the operation management, with the monitoring and the events and alarms, all built into one product. And we touch on a little bit about the workflow and being able to leverage any of your ticket system and your approval processes. Okay? And all of these, while we cover a lot of the ground, and ISF provides a lot of these functionalities out of the box, it is just one product. And that was one of the key attributes, one of the project drivers they're looking for is one simple integrated solution that helps them to manage the whole life cycle from request to reclaim. So to summarize with respect to the value, and again now going back to the original VMware case that was at the core of the phase 1, I would say the phase 1 of the cloud project, very VMware focused, and just kind of looking at it from a comparison perspective, as we mentioned, it's one product called ISF that covers everything from chargeback to self-service to workflow and approval, allowing you to look at choices of external, right? Not just VMware service providers, but also things like Amazon, things like Rackspace. Those are all capable and possible with ISF because of the open architecture. And then finally, with respect to the underlying physical virtual infrastructure, ISF works with any vSphere edition. Obviously, when we talk about being able to support and leverage the DRS capability, the customer would be running the appropriate edition to support that. But ISF supports any vSphere edition, and it gives the customer an option of also tying in other hypervisors into the system. And as we mentioned earlier with the example of the 3-tier application, you can also include physical servers as part of the deployment of the cloud services and the application services for the end user customers. Okay, so with that, I will hand back over to Jay.
Okay, James, thanks. I think that was a great explanation of the customer situation and, what they went through. We had a number of different questions that came out throughout that discussion, and I tried to address a number of them live. But, James, a couple ones I think might be good just to, recover as part of that discussion was, how long was the process for them in terms of, from initial concept, who was involved in the project to actually, going out and developing a cloud? Did they go through some concept of a proof of concept?
From you. Right from the beginning when we talked about the, again, going back to the idea, right, of cloud needs to be built and not bought, and the three attributes of cloud being people, process, and cloud technology. A good 6 months was spent on the earlier phases of engagement with the lines of business, in engagements with the local admins to define what types of services, to define even the requirements. So a good 6 months was spent there. Then it led to on the vendor selection side, technology side, this organization was very, very tight, very efficient. Obviously, look at multiple vendors, and typically went through a 3-month POC, and from there went through another further 3 months to define. Okay, great. Now we understand we chosen a particular vendor. Okay, what are the things you actually need to implement now? Against to actually get to first production. So the first production then would be another, I think 3 to 4 months type of milestone. And that's not the end of it. As we mentioned earlier, cloud needs to be pragmatic. Cloud, that is creation of cloud projects run on cloud, needs to be pragmatic, and think of that as release 1. And now moving further is taking the same iterative approach, POCing on the next set of requirements, and then working at implementing it so that they're going to get to a second release and go from there. Typically, we have seen with in general 3 to 5 months cycles is a good way to go from one milestone to another, and cloud needs to be built iteratively.
Great. That's a great answer. And I think that is something important to reinforce, that with a lot of the accounts, not just the one that we talked here, is that they typically have that first use case, and a lot of times it can be around the concept of self-service, and taking it down from 5 weeks down to hours or minutes, depending upon the use case they're trying to do. But then typically it's an iterative process where then they start looking at moving up the application stack. So not just serving up a VM, but actually serving up the more complex multi-tier environments with the middleware and potentially a complete, fully provisioned application. And in many cases, our customers call those a platform type of environment, or even a SaaS type of environment that, from their perspective, really allows them to get a lot more productivity out of their organization. But I think that once you then also can think about another dimension that a lot of our customers go down, is they move from just the agility self-service type discussion to the longer running applications, where they do want to build in that application flexing depending upon the SLA requirements that they need to manage in their organization. And, if you think of those as almost two different dimensions, and companies will go across them depending upon their own specific business cases. But what's nice about this is, we talked about multi-line of business, so it doesn't necessarily just have to be a larger conglomerate enterprise with, what you typically think as big business units. It could actually be departments within a business unit, and that each of those departments have own specific unique needs, and they can't agree on how to consolidate everything. They can't agree on making all those trade-offs, and in this manner, they don't have to. So for people that are on the end of having to build out that architecture and actually instantiate a cloud environment, you can actually think about that project plan. We had another question about, how does this help me as a project manager? And I think that gets to the crux of the issue, is that you don't have to come out with a least common denominator where no one's happy about the cloud that they receive. You can actually allow for a lot more unique line of business requirements and allow them to self-manage it, because a lot of these business units don't want to give up the control. They still want to feel like they have their own area, but with the consolidation, they can get the feel of having a much larger environment and infinite amount of resources when they potentially can be normalized out across the different business units. And so you get all the benefits of cloud in terms of the consolidation without having to give up that control. And that's really, I think, where we're seeing a lot of value in what we can provide. And that kind of gets into this, one of these last slides as a summary, is some of the things that we think are very important to look at when you're going out and going down your cloud projects. How can you allow that consolidation with control? Don't force either the business units or the departments within a business unit to have to go with that least common denominator. Allow them to still manage and control it. Then the second point being comprehensive. Do you want to buy a whole bunch of point solutions and have to stitch them together to build your cloud? James talked about, how do you make it, almost like that Apple experience where someone can come in, single push button, and they get what they need. And you don't have to worry about, putting together or stitching together things. But it's also, we do find in a lot of our customers, they do have, potentially a portal that they want to leverage. And in some of those cases, we just connect into that so we can fit within the existing infrastructure and just become part of the natural business process. Third one about the open architecture, I think James did a fantastic job. A lot of companies have made significant VMware investment, but they don't want to have lock-in. And they want to be able to know that 5 years from now, if the technology landscape changes, that they're not just tied into one vendor's silo stack. And, that's across a lot of different mega vendors that are really kind of pushing that. And how can you maintain that flexibility as a company? And also, as things evolve, maybe you do want to transition to more commodity-based components. If you don't need, certain, higher level functionality, and how can you make that process a lot simpler? And then finally, this last one, enterprise grade. Coming back to who is Platform Computing, it is a $100 million company with a long history of working with companies that are global, that have organizations that are around the world. And we can provide the support that you need for not only these non-production use cases, maybe around test, dev, and how you set up those infrastructures as a service, but also as you move more into the production side, making sure that you have the confidence, that your CIO has the confidence at night that their environment is going to be running and optimized for the business. And that, I think that we've had a good number of other questions. One of the questions was, other potential next steps if I wanted to learn more working with platform computing. And this is where you can actually reach out to me and or James, and we're happy to help coordinate either a discovery day or an executive briefing where we can help you think through how do you approach cloud, what could your journey along the cloud evolution look like, and then potentially even go to the point of doing a proof of concept. That's what the POC is. And or you can actually go to our website right now at www.platform.com/private cloud, and you can learn more about our solution. But you can also download a free 30-day trial if you want to. We do have other webinars, and we're also up on Twitter. So with that, I think we've reached the top of the hour. I very much appreciate everyone's time today. Hopefully you found this informative. And we hopefully will be hearing from you in the future. And good luck with your cloud initiatives, and have a great day.